All right, welcome back. So right now we're going to build our eighth project. Okay, so this is part of our Arduino basics for absolute beginners. So what are we going to do right now is the Arduino Ultrasonic alarm. Okay, so this is the diagram for our ultrasonic alarm. As you can see, we have here different components. The first one is our alarm, the buzzer. And then the second one is our resistor. And then the third one is our LED. And the last one is our ultrasonic sensor. So this is an ultrasonic sensor. It is a module, and I will show it to you after I explain this diagram. Okay, so this module has the 5 volts pin and the trigger and the echo. The trigger should be connected to our PWM digital pin 9 or PWM 9, and then the echo should be connected with the pin 10 PWM. Okay, so 5 volts will go to the 5 volt supply of our Arduino Uno, and then the ground goes to our negative. So this symbol says that the connection goes to our ground with the Arduino. Okay, of course our LED circuit and then the buzzer. So let's see that in actual. I'm gonna open first our simulator. Okay, so I'm gonna go ahead to our walkway, and I have started already the simulation, as you can see. Okay, so I'm gonna tell you first about the sensor. This is the ultrasonic sensor. So I'm gonna zoom a bit. There, as you can see. And later I'm gonna show you the actual. Okay, so this is an ultrasonic sensor, and the work of this sensor is to sense any motion or any obstacle in its way. Okay, so there are ranges, or there is a range for this which will be used and will be effective. Okay, the range of this is around 400 centimeters. That is, I think that is the 400 centimeter to meter, that is 4 meters. Okay, in a distance from the object to the sensor. Okay, whenever the sensor sense any movement, or let's say an object, it will sense it. Okay, the movement that I'm talking about is not the motion. Okay, it means to say if there's anything that obstruct its sense. Okay, it sense something that obstructs. Okay, so it will detect it. Okay, it's a detector. All right, so I hope you get that. And the work of this will be a for burglars, for what you call the path, anything in the path that it senses that it is a block, so it will just throw the signal to the Arduino, and the Arduino, it depends on the program, so we can utilize this, so we can create more interactive projects. We can create robots, cars that would detect its way, something like that. Okay, all right, so here in our diagram, as you can see, I have already installed the wirings, so I'm gonna color the connectors so that you will go along as I explained. So this line to our LED negative, and this one is for the positive of our LED. So I'm gonna color it with red. Okay, so make it a habit that you colorize your connections so that you will have a more understanding what's happening with the circuit, just in case. All right, so I think that's better. And the trigger, we can color this, the trigger of the trigger pin going to the 9th pin. So I'm gonna color this, let's say, yellow. And this one, let it stay as green. Okay, so this one, I have to change this to ground because I need it to, yes, so that I will know that it's the ground. Okay. All right, so this is the connection. Our buzzer goes to pin number 8 and our LED to pin number 7, and then of course our trigger goes to 9, and then the echo goes to 10. Okay, so this sensor will send the echo to our Arduino, and we will know the orientation of each pin here in our code. So this is our code. I'm gonna put some space and move it to the second line so that we will know that there's no code above our code, our line 2. Okay. All right, so here we define the trigger pin as the pin number 9. Okay, so this one is different now. Before we use the constant and the int, but right now we have used the hashtag define to define the trigger pin as 9. Okay, define echo pin 10, and then we have the LED pin 7, the buzzer pin 8. So this is a bit different. Okay, so we are defining and saying to the program compiler and Arduino that this trigger pin is assigned to 9. It's a bit different to the to our previously used constant and the int. Okay, but later on I'm gonna explain it furthermore as we proceed. Okay, so pin mode trig pin is output, echo pin input. So as you can see, the echo pin now becomes the input. Okay, echo pin is in the pin number 10. Okay, so it will become an input, meaning to say that the echo will send signal to our Arduino. All right, so LED pin, of course, we have been familiarized with this. It will be the output, and of course the buzzer pin. Okay. All right, so next line is the void loop. Long duration, so what's this? And distance. So here we are telling the Arduino, and we have used this function long duration distance, and because we will going to use distance in measuring the centimeters, okay, in centimeters, so that our sensor would detect any object that obstructs its way. Okay, so here I have put the comment clear the trig pin. Digital write trig pin low. Okay, means to say that the trig pin should be low. Micro or delay microseconds 2. This is a value for our delay in microseconds. Digital write trig pin high. Okay, for 10, let's see, what's that 10 microseconds. Okay, so this will work for microsecond, 100 microseconds. Trig pin low. Okay, so here we can see that the function of the sensor should be triggered through its trig pin. So here it is, the trig pin. There. So this is the code for it. The next is the duration for pulse in, echo pin high. Okay, so that would send a pulse to our echo pin. Then this is the distance. Okay, so we have declared in the first part of the loop the distance and then duration. Of course, we have said that the duration is this is a variable. Okay, as you can see, duration is equals. Whenever we see the equals sign, it means it is a value. Okay, after the equal sign, there is a value. So the value would come from echo pin, and it should be high. Okay, whenever the echo pin have the high, so the duration. Okay, so the duration, and then of course the distance. Duration multiplied by distance. This is the part of our distance. 0.034 divided by 2. Okay, so this is our distance, our variable, and this is the value. Okay, and next is our if distance is less than 10. Okay, so what kind of 10 is this? So we are using the centimeter. Okay, so this is in centimeter. So it means to say if the distance is less than 10 centimeter, then you have the Arduino have to write the LED pin high and of course the bus pin high. So it means it will alarm and light up the LED. Okay, and then the tone should be set to 1 kilohertz. Okay. Okay, so else digital write LED pin low. Turn off the LED, no tone buzzer pin. So the else means that if the distance is not less than 10, so the LED will remain off and the buzzer will remain off. But if the distance is less than 10, meaning to say it's near the sensor, the distance between the object and the sensor, if it is less than 10, then the buzzer and the LED will light. Okay, so here the last line is our delay 100. Short delay before the next measurement, meaning to say that it will return to its loop. Okay, so let's see what will happen. Okay, the void loop, what happened? Okay, of course, because I've just adjusted the, okay, so it's complete. We already have the closing bracket. So let's try to simulate this. Okay, so as you can see, the LED is not turned on and the buzzer doesn't sound. It is because the sensor is sensing 21 centimeters. So we can adjust this 100. So it still the sensor or the alarm doesn't work. Okay, so because we have put in here the less than 10, so let's try the less than 10. Okay, so there it is. So whenever the sensor would sense anything at the distance of 10 centimeter, it will trigger an alarm. So we can change the value, of course, for our distance. We can set it to 100. This means 100 centimeters. Just I have told you, this sensor can sense to about 400 centimeters, as you can see here. Yes, the simulator gives us the information that the sensor can sense up to 400 centimeter. So I'm gonna restart the simulation with the new value, the 100. Okay, so right now I'm gonna change it to 100. See? Okay, so if you will ask the accuracy of this sensor, yes, it does have a good accuracy with that range from 20 centimeter to around 380 centimeter. It is a bit accurate. Okay, sometimes there are problems and errors because of the connection and probably the sensor sometimes malfunctioning, but there are good sensors made by famous brands like the DF Robot and other brands that you can rely to have a good accuracy with the sensing. Okay, so we're gonna try that to our actual. Okay, so I'm gonna use the 100, but I'm gonna revert this to 10 because my space is a bit a bit narrow, so I have to use a lesser value for this, because if I've set that to 100 centimeter, of course there are obstacles on the way, so it will immediately sense that there are obstacles. So I'm gonna set that first to 10 and copy the code, of course. All right, and open up our Arduino IDE and prepare the code before we can see the actual. I'm gonna open a new sketch. Sorry. So there are some messages here. Just close it if you don't need the libraries, so it's okay. Later, I'm gonna talk about the libraries. Okay. Here, I'm gonna paste our code and I will try to verify it first. Okay, so it's verified, means it will work, and I'm gonna go ahead and show you the actual of our sensor. So here it is, and also the wiring. I've already made the wiring to make sure that everything will gonna work. Okay, so there are two types of sensor. I'm gonna pull out first the sensor, and as you can see, this is a different one from the one we simulate. It is the HY SRF05. So, and it has 5 pins. Okay, so there it is, our the VCC, which is the power. We'll connect that to 5 volts. The trigger, the echo, I think this one is for the 9 pin, 10 pin. Let's check that again. And this is, it has the out, but we didn't use the out, and the ground, of course, to our ground. So this one, it can be used to our project. And another one is, of course, this, the one we use in the simulator, the HCSR04. Okay, so it only has 4 pins. Okay, the VCC, trigger, echo, and the ground. So any of these two can work. Okay, so I'm gonna try first the 5 pins. Okay, so make sure that you do accordingly to what our wiring diagram says. So I'm gonna show you first the diagram. There's a diagram here. I hope you can translate this to actual. Okay, 5 volts, then trigger to D9, echo to D10. Okay, let's go back to our video or to our camera. So I have colored the voltage as red, and the 9, the two the trigger and the echo, and of course the ground. So you can easily see that this should correspond to the diagram. Okay, so as you can see, the red goes to 5 volts and the black to ground. Okay, and the green goes to 9 and the blue to 8. I'm sorry, the white goes to 10. The green goes to this here it is. The white and the green goes to 9 and 10. Okay, 7 goes to our LED, and then the blue goes to the number 8 to our buzzer. Just like what we have in the wiring diagram. Okay, let me show you again. Okay, the 8 goes to our buzzer. Alright, so I'm gonna insert the 5 pins. Okay, so the first one is our VCC. So that first pin should be on the red one. Okay, there. Okay, so it's a bit loose, so you have to make sure that it's connected properly. Also the connectors, the wirings, you have to make sure that they have a good connection. Okay, so I'm gonna upload the code. So here it is. Connect the I'm gonna upload the there. So it's being uploaded. Okay, so it's already sensing something. That's why it's very noisy. I have to tilt it because there's the wall, and reset first. Possible it's a bit loose. That's why okay, so I'm gonna hold the sensor first because I think it's losing connection. See, it's work. It is now working. So there is some problem with my connection. Okay, so you have to make sure that the contacts are good. So anything that blocks its way will cause the alarm to be triggered. So you can use this to any purpose that might fit the design, or you can use this in the door or through the door, or you can install this so that whenever someone comes in would give you a trigger that there's somebody at the door. Okay, so there are a lot of purposes for this. Some they use this for a car, okay, a miniature car or a robot car that would sense the wall, that would sense any object that would obstruct its way. Okay, so the robot will turn the other way and see for a path. Okay, so this is useful, so I hope you would try this project. Okay, so think about anything that this project can be useful. Okay, so there's an object the wall. I mean, there's the wall. That's why. Of course, you can adjust the distance. Okay, you can set it to the maximum of 390 centimeter, because that is, according to the documentation, that is the maximum accurate distance for the sensor. Okay, so would you like me to try this one too? Okay, for the sake of learning, I'm gonna put this the way, but of course it has only 4 pins, so I have to adjust the ground there, so it accommodates all the 4 pins. So I'm gonna use a battery to simulate the to power the Arduino. Okay, so right now let's try. Okay, this one is better, as you can see. If you were able to do this and make it work, congratulations. All right, so that's it for now. I think if you have questions, you can message me through the comments, and I'm gonna answer you as soon as I can. All right, so let's proceed to our next project. See you on our next lesson. Bye bye.